Hi, good morning students. This is Harsnath Sukla and today in class 12 we are going to discuss lecture number 6. Chapter is continuity and differentiability and topic is the relation between the continuity and differentiability. That means one theorem from NCERT we have to take here. So write down, if a function y is equal to fx, theorem this is, if a function y is equal to fx, y is equal to fx is differentiable at x, is differentiable at x is equal to a, then it is also continuous at x is equal to a. Then it is also continuous at x is equal to a. So we are going to see this particular theorem. If a given function is differentiable at x is equal to a, then it must be continuous at x is equal to a. So let us begin. Maybe you note this statement. So proof of this particular equation, theorem: if x is differentiable at x is equal to a, let fx is differentiable at x is equal to a, then we can write here limit, we can write here limit x tends to a, fx minus fa divided by x minus e. If fx is differentiable at x is equal to a, then we can write it as this, and this is nothing but f dash e. This is the differentiability of the function at point e. Now in order to show so fx is continuous at x is equal to a, x is equal to a, we need to show, what we need to show, limit x tends to a, fx, this must be f. Okay, if a function is continuous at x is equal to a, then this is the definition actually. What? Limit of the function is equal to the value of the function. So please note it down. Okay, now we can write it as limit x tends to a, fx, limit x tends to a, fx, this is nothing but limit of x tends to a, fx minus fa divided by x minus a into, if you want you can write limit x tends to a, x minus c. Okay, because according to the definition of and plus limit of x tends to a fa. Okay, limit x tends to a fa. Why? Because you know, if we apply the algebra of limit, then this is this is cancelled out. Limit x tends to a fx, minus of limit x tends to a fa, and this is the plus. So the whole equation is balanced actually. So we can write it as limit x tends to a fx is equal to, this is what, f dash a, limit x tends to a, this is what, f dash a, f dash derivative of the function x equal to a into limit x tends to a x minus a plus limit x tends to a fa. So you know, if you put the limit, this becomes 0, so this is 0 plus limit x tends to a fa, and this is simply fa. So what we saw here, limit x tends to a, fx is nothing but fa, that means limit of the function is equal to the value of the function. Hence we can say the function is, when the function is differentiable, then it is continuous also. A function is differentiable, then it is continuous also. Okay, so next we shall discuss some questions. Now let us see. This is NCERT problem, so please see. Prove that the function fx is equal to x minus 1, x belongs to R is not differentiable at x equal to 1. Now, we are going to discuss a question. Prove that the function given by, prove that the function given by fx is equal to mod of x minus 1, x belongs to R is not differentiable at x equal to 1. For each x belongs to R is not differentiable at x is equal to 1. Okay, so we are going to solve this particular problem, that we shall discuss the differentiability of the function at x equal to 1. So solution, first of all we define this function fx as, you know, this is x minus 1, negative of x minus 1 if x is less than 0, less than 1. At 1 we define it, okay? And this is x minus 1 if x is greater than or equal to 1. Okay, this is the definition of the function. If you want, you can write it as 1 minus x also, because minus of x minus 1, this is 1 minus x. So this is the definition of the function. Now we can discuss the differentiability of this function. So first we find LHD, that means left-handed derivative. This is LF dash 1. Limit x tends to 0, f of 1 minus h minus f1 and divided by minus h. So you must learn the definition of differentiability, then only you can solve the problems. So this is limit x tends to 0, f1 minus 2h, that means the quantity less than 1, and this is defined as 1 minus x. So 1 minus of 1 minus h minus f1 at x equal to 1, this is 0. See, x is equal to 1 if you put, then this is x minus 1, that means 0 divided by minus h, and this is 1 cancel, this is minus h upon h. So limit h tends to 0, this is minus h, 1 minus 1 cancelled out, this is plus h upon minus h, and this is nothing but minus 1. So LHD, that means left-handed derivative of this function is minus 1. Now we are going to find right-handed derivative. So please note it down. Okay. Now RHD, right-handed derivative. Now right-handed derivative. RHD, right-handed derivative. So what is right-handed derivative? See, R f dash 1, this is limit h tends to 0, f of 1 plus h minus f1 divided by plus h, this is limit h tends to 0, f of 1 plus h, that means the function is greater than 1 and it is x minus 1, that means 1 plus h minus 1. From the definition of the function which already defined, then this is 0 divided by h, and this is cancelled out, so this also becomes limit h tends to 0, h upon h, this is 1. So from the above results we can see here LHD does not equal to RHD at x is equal to 1, since left-handed derivative at 1, right-handed derivative at 1, both are not equal, they does not equal, that means function is, so function is not differentiable at x is equal to 1. So this is the solution of this particular question. So let's see next one. So please try to solve questions. So first we discuss the differentiability of the bracket function. Differentiability of bracket function. Now let us see. This is a topic also, and some question based on this. So please try to understand. We are going to discuss the differentiability of bracket function. Differentiability of bracket function, and you know very well what is the bracket function. This is the bracket x, this defined as the greatest integer less than or equal to x. You know very well this is the bracket function, greatest integer less than or equal to x. That means what? If you consider in bracket 1.2, then this is what? 1. Why? 1.2 से बड़ा, सबसे बड़ा और उससे छोटा इंटीजर कौन सा है? 1 है. That means the integer less than, greatest integer less than or equal to 1.2 is 1 only. Suppose this is minus 1, then this is minus 1.2, this is minus 2, because the greatest integer less than or equal to minus 1.2 is minus 2. So this is the definition. Now we are going to discuss the differentiability of this function. So suppose fx is equal to bracket x. So we are going to take differentiability of this function. So there are two cases. The first one is at integral point and the second one is non-integral point. So suppose case first, at x is equal to c, and this is where c is integer. Where c is integer. Remember, c is integer. So limit this differentiability, that means LF dash x, if you find, then this is limit x tends to 0, f of x minus f of c plus h minus fc divided by minus h, c minus h minus fc divided by minus h. Okay? So you know very well c minus h. If c is integer, then c minus h is obviously not an integer. So c minus h, that means what? This is c minus 1. Why? C minus h, so less, suppose c is 2, 2 minus something, this is 1.3, 1.4, then this is 1. So why 2 minus 1? C minus 1, and this is fc, fc is integer point, that is c only, and this is minus h. Okay? So this is cancelled out, this is limit h tends to 0 minus 1 upon. So limit does not exist. You can say limit does not exist. Hence the function is not differentiable at integral point. Okay? So we can say the function is not differentiable at integral point, but if you consider non-integral point, then it should be differentiable. Why? Because limit does exist and equal to the left-handed and right-handed derivative. Okay? So bracket function is not differentiable at integral point, but it is differentiable at non-integral point. So we can discuss a proof that greatest integer function defined by fx is equal to bracket x, where this is question number 2 from NCERT. Fx is equal to bracket x, okay, defined by fx is equal to bracket 0 is less than x is less than 3, is not differentiable at x is equal to 1 and x equal to 2. Defined by this, 0 is less than x is less than 3 means we have x as the x between 0 and 3, and this is not differentiable at x is equal to 1 and x is equal to 2. On both integral point, this is not differentiable. So let us see. At x is equal to 1, we are going to find RHD and LHD. So at x is equal to 1, RHD, R f dash 1, this is limit h tends to 0 f of 1 plus h minus f1 divided by h. Okay? So f1 plus h is what? If we consider 1, then 1 plus h, the quantity h greater than 0, so this is limit h tends to 0 bracket of 1 plus h minus f1, this is 1 only divided by h. So this is what? 1 plus h is the 1 only. Why? Because this defined as the greatest integer less than or equal to 1. So this is 1 minus 1 divided by h, this is 0. Now LHD, left-handed derivative, LHD, so this is limit h tends to 0 f of 1 minus h minus f1 divided by minus h, and this is limit h tends to 0 f of 1 minus h, this is bracket 1 minus h minus f1, this is 1 only, and divided by minus h. So you know very well, this is 1 minus h, and this quantity is 0, so this becomes limit x tends to 0. This is 0 minus 1 upon minus h. This is limit x tends to 0 f of this means 1 upon h. So if you put h, then this is not defined, that means limit LHD, that means left-handed derivative does not exist. So we can say this function is not differentiable at x equal to 1. Similarly, we can find for x is equal to 2. So in this manner, we had to complete our topic differentiability, and tomorrow onwards, that means next lecture onwards, we are going to start differentiation. This is the major part of the major and most important part of the calculus, differentiation. So let us begin differentiation on next lecture. So thank you for today.